Let us start lecture 2 of this module number 4. In the previous lecture, I discussed the 3 mall operation of converter circuit. I discussed the arc back, arc through and misfire. Today I will be discussing the 2 converter problems. One is your arc quenching and second one is very popular, that is a commutation failure. Basically, most of the, if it is your misfire or it is a arc through or it is arc quenching, in the inverter side that is a similar impact like a commutation failure. So, the inverter is the most serious concern is the commutation failure, because we will again discuss it due to the voltage reversal in this incoming wall. So, here I am first, let us see what is the arc quenching. This arc quenching at its name, basically it is used in the mercury arc valves. It is not in the normal thyristor, because normal thyristor, once you are giving the pulse, either it will conduct or it will not conduct. So, the misfire can happen in your normal the thyristors or GTOs or IGBT grade of valves switches, but the arc quenching was basically used when the mercury arc valves were there. The mercury arc valves, there is a ionization process takes place, and due to the ionization, even though after some ionization again it is going back, so it is called arc quenching. Means just like it is a chopping. Once it is starting to conduct and is coming back, it is just similar to the misfire, I can say, and it happens in basically the old mercury arc valves. So, that is why here it is this malfunction has the same effect as misfire almost, and cause the short circuit to the DC terminal, like a misfire also sometimes it gives the DC short circuit. Here also it will give the DC short circuit as well. So, I am not going to discuss much in detail, because it is in the modern converter circuit in HVDC used, it is not a big deal, it is not happening at all. So, major is your commutation failure, and this commutation failure only occurs in inverter side, and this basically mal operation, or you can say fault, which is very common in inverter, very frequent, and it is a result of failure of incoming valve due to the insufficient extension time to take over the directed, that is a DC current from the before the commutation voltage reverses its polarity. Here again, if you will see, I will draw the commutation voltage of valve 3. Here this is, if you are firing here, that is your beta degree, and there will be some U period, and this is a commutation voltage is reversing. If your conduction is start and going beyond this, at this point you can say the voltage is going to reverse. So, what happened, the valve, this is your EBA, means it is off valve 3. So, here once valve 3 is going to be fired in the inverter circuit, we are just delaying here. So, if it is conducting here and it is commutation is not successful before this zero crossing, then there is a most possibility, because the voltage is reversing, and then what will happen, the current which was taken by 3, it will be going back, and your previous valve, that is again valve 1, because in upper bridge it is 1, 3 and 5. So, 1 was conducting earlier and 3 was fired. So, the commutation will be not successful if it is delaying much here, and this is the happening. It is not always necessary, even though sometimes you have come to this point even, and there is also possibility the commutation is failure. Why? Because this rate of here the voltage which is going down, and now you can see the polarity across the valve is going to be positive. So, this voltage is increasing, and but current was decreasing in valve 1. Here in valve 3 current is increasing, voltage is decreasing. So, at near to the zero crossing, before that if it is not successful, then there is a possibility of the commutation failure. Means here I can say, if you are drawing your current here, now let us suppose this is your I1 current which was ID here, and your I3 was 0, here I3 was 0. Now, the commutation is starting. Now, this will, because it is a fired, voltage is positive. So, the current will here, it will be increasing, and this will be here decreasing. Now, there is possibility that here, even though this is coming here and again it is coming back, and this has taken and it is coming back here again. So, especially here the near to this zero crossing, if it has crossed, certainly there will be commutation failure. But even the before also there is a possibility, because here it is the voltage is very less across this and is decreasing, there is a possibility this current I1 is decreasing, but suddenly it is start increasing because the voltage across is becoming positive very faster rate, and this is going to be negative this side. So what happens, this the commutation was taking place, but it was not successful, means we want that in actual case this should take the complete current here and this should go 0, and we want this, and this is called the commutation bolt. So that is why it is called the commutating bolt is reverses its polarity. That is very well here. If it is not successful up to here, in this case it will be failed, because here the polarity is reversing. Here it was positive, here it is going to be negative of the commutating bolt. So due to this result, is said the direct current shifted back from the incoming valve to the outgoing valve, because the 1 was outgoing valve and 3 was your incoming valve, and the current is reversing back, and it is finally this I1 is taking place, this complete current. Now the major cause for this, you know, we are using the inverter side, the CEA control, the constant extinction angle control here, that we are maintaining gamma minimum here, that is why 10 degree, because here it is not saying 5 degree, because we are maintaining larger portion as well, because we want that it to be sure there should not be commutation failure, because the impact of the commutation failure will give you your reduced voltage, it will be trying to interject the harmonics in the system, and there will be the DC short circuit across the inverter circuit, which we do not want. So here you know the beta is calculated, already I explained the how the CE is working, this constant extinction angle control. To maintain this, we calculate the beta based on the excitation condition, but there is a possibility the current in the valve is increased, not due to this side, due to the problem in the another side converter, because the current in the DC link is basically the voltage difference between inverter and current. Here this is your voltage, I can say this is a rectifier circuit. So this voltage whatever there, this is your resistance of this line, and this is your inverter here. So this current which is flowing, it is basically here VDI here VDI and here VDR. So the voltage difference divided by R will be the current here. So even though there is no problem this side, problem may this side also cause the current increase. Once current is increasing, the possibility of this your U can be shifted. So if you are landing this side, then commutation failure will be there. So it is the malfunction valve due to the either AC side problem or the DC side problem condition outside the bridge, or it is due to the increase the DC current. As I said, if the current is increased, then you will be more. So this is one cause, and another the possibility here the voltage either this side and this side has a very severely low. If voltage is low again, then your U will be more. And finally we can go for this here. What happens, the voltage is reduced at that time, because in calculation of beta we use the EM, and also we use your this current is also appearing in this. So this beta calculation, once you are calculating and then even though happens, then we are just the commutation failure will be there. Sometimes here due to the late ignition of this, means you have calculated beta here exactly the same, but due to the controller it is trying to say that you have to delay it 5 degree. Yeah, you have given the pulse generation is delayed by 5 or 6 degree or something, then again it will be shifted this side. So either your DC current increase, either the low voltage AC side networks, or your delay in this firing angle here will lead to your commutation failure, or it may be combination of these even, not only individually, the possibility the current is also increased and the voltage is less this side. What happens? The commutation failure may occur. So that is why it is written the late ignition or the combination of all these three problems may lead to your commutation failure. So here one sentence I have written, that nearly all the inverter valve fault lead to the similar phenomena like the commutation failure. If you will see the misfire is also some sort of the same, if you will just draw the misfire, you will find it is the almost the phenomena the DC dead short circuit. There is a possibility of the next valve will be not conducting to the negative voltage, we will see here for the commutation failure. So it will give you the nearly same result as other faults in the inverter circuit. So that is why it should be discussed very carefully, and it is very common as well, because always you are calculating beta and you keep on changing due to the system and network conditions, and it may happen. So failure of the two successive commutation in a same cycle. You know, there is a possibility if, so as I said here 1 and 3 commutation was unsuccessful. If it is only one commutation failure, now I can say this is one commutation. failure is there in one cycle, then it is called single commutation failure. But there is a possibility that in the same cycle there is a two commutation failure, means it suppose it is a 1 and 3 is failure. Now after that we will find, let us suppose the 2 and 4 is failure and so on so forth, then there is a double commutation failure, and that is a very, very serious. So in that case what we do is, if it is a frequently occurring even the double commutation failure, then we have to block the bridge or we have to bypass it. So we will discuss the double commutation failure as well. To understand and see what will be the output voltage and what will be the sequence, now we have to assume, let us 1 and 2 are conducting, and now valve 3 is given the pulse and it is igniting, but after certain time it is going to be the commutation between 1 and 3 was not successful, and it is current is not complete, and it is going back to again valve 1, and 1 and 2 again are conducting in the next sequence as well. Then we have to, we are firing the valve after every 60 degree. So the once 1 and 3 was unsuccessful, then the next valve will come at the 4. We have to give the pulse to the 4, and the 4 will conduct, because the voltage across this will be positive, and this will lead to your dead short circuit, because 1 4 in the same limit is conducting, so DC short circuit is appearing. So it will conduct. Then here as I said, the 2 and 4 will be successful, and only valve 1 and 4 will be conducting now. So this is a dead short circuit. Now next sequence of the valve will be 5. The pulse will come to the 5, but this will not conduct. We will see, because the voltage across this will be negative. Because once 1 and 4 are conducting, we will find the voltage across this in inverter operation, the voltage across your valve 5 will be negative even though pulse is there, and it will not conduct. So what will happen? Again 1 and 4 is continuing. So next turn will come to the 6, and we will find the 6 will conduct, because 1 and 4 commutation will be successful. If then again 6 and 1 pattern is coming, then after that 1 is coming, which is already conducting, so there is no problem. So 6 1 will continue, then 2 will come, and then it will be your 1 and 2 will be there. So in whole cycle you can see it is now we got our 1 2 pattern, and finally we are also getting 1 2 and so on so forth. So it is automatic clearing. So the commutation failure is a self clearing phenomena in the single cycle if it is a single one. To see this, let us, there the various type of possibilities are there. Same thing I said here. Let us see, this is the, I can say the voltage. To explain here, this figure is basically nothing but your line to line voltage. If you see here, as I said, at the point A here, at point A, before that your 6 and 1 were conducting, and 2 was given pulse at the A point, and you can see here also the commutation here, this 2 is taking complete current, and here 6 is going to be 0. So the commutation between 6 and 2 is successful, and then at the point B only valve 1 and 2 are conducting, and you can see this voltage here, it is the negative voltage which is appearing here. Similarly we can see the figure A here, it is nothing but it is the positive and the lower side the voltage of this your DC terminal, and the second one is the line to line, it is the difference between positive and your negative. Here you can say it is said it is a VG positive, and this is your here the negative one, the voltage is appearing. So to see this, what I can do, I can draw again our 6 pulse bridge converter circuit, so it will be more clear why the voltage will be there. This is your valve 1, here your valve 4, here your valve 3, we are having valve 6, here we are having valve 5, and then we are having valve 2 here. So this is your phase A, here your phase B, here phase C. Now with this, now we can see, we can start from the top figure. You can see at the point A here your the valve 2 is given, means before that your 6 and 1 were conducting, means your voltage was 6, here it is your B, here your A, means your A was here in the positive side, and here B was there in the negative side. You can find here it is the same. You can see EA here is the positive, here at this point, and this side your E B was there, and that is there. Now, we gave the pulse to 2. Now, this is your 6 and 1 were conducting. Now, we are giving pulse here. Now, this voltage will become your E A by 2 minus, because this 6 and 2 are conducting, going to conduct. So, here it will be B and C by 2. So, we are going to have this, and this is your E A is still there. So, you can see here still we have the E A. E A is following here during this period even though commutation, but this has half of this with the negative side. So, this was your positive. So, it just reverse here half of this magnitude here. So, it was this voltage in the negative side. Once commutation is successful, we believe that commutation is over. Now, after that here, now this negative side voltage is going to be 2, that is E C, because 6 is over now. So, the 2 is there, and now 2 is your E C is taking place here, but still here is the E A is going to be there because 1 is conducting. Now, at this point here at the C, now this is a chance of C or valve 3. So, till here at this point, as I said, now here the successful, now here this is a valve 3 is to be given the pulse. Now, this is the case I am taking. This valve was expected to receive a gate signal at this red line, but due to some problem there is a delay in the ignition. I am not saying it is due to the voltage down. If voltage down also, then it will conduct here, and then it will follow this one here. It will be like this, half of this. But it was given here, the pulse was expected, but it was delayed by 5 degree, let us suppose. What happened? Now, it is delayed slightly. Once it is delayed here, means it got the signal at the C pulse, and it will conduct, because you can see the voltage across this, it will be positive. How it is positive? This it is we require for 3 is the commutation voltage is E B A, and E B A you can see it is your A, this is a B, B minus this is positive, and it will conduct. You can see at this point here it is a negative, and this is a still 0. So, it will be positive and it will conduct. So, it will conduct at the C point. It is believed here that it is a 5 degrees delayed. There are so many conditions are there. It means even though it can conduct here, and due to the network condition during that after conduction, maybe voltage reduced and U is delayed. So, it will be continuing here. So, let us first see here, we are giving the pulse here, but it is delayed and we are giving the pulse at this. Now, if you are giving the pulse at the C point, what will happen? It will be the, you can see the current now it is going to increase in the valve 3, and 1 here it is going to decrease, because this is your I1, this is your I3. So, we get the pulse here. Now, it is going to be here. Now, you know, as in the regular practice, what happens, the here you at this point, this is a delayed, and at this point we have to give your, the commutation should be here, should be over at this point, but it is now delaying, and we are expecting that here current was increasing and it was not successful, and this you can say it is again it is picking it up. So, what will happen? It was even though in normal condition at this point the commutation should be successful by this, and then your 2 and 3 should continue, but it is not happening. So, the dotted line shows that if there is no commutation failure, dark line is saying that there is some commutation failure. So, what happens here? You can say if it is continually conducting, so here you have given the pulse. Now, this will be the half of the line voltage, you can say. Now, what happens? 1 and 3 here, your positive side voltage will be E C minus E C by 2, and this side your 2 is there, so it is E C. So, you can see here we are having E C here on the top of this, and minus E C will be this side half and half of the magnitude. So, this is your, this will be curved like this. So, it is just following here, and it is now increasing, and your commutation even though it is not successful till this, and now at this point here, now there was turn of valve 4. You can see here at this point E, after 60 degree. Now the possibilities, the various possibilities are, there is a possibility the commutation failure between 1 and 3 is before E or even though after E. You see this point here very clearly. What is in this case? There is a possibility here, this is a increasing and it is have taken even though well before, that's even though you are firing of the sequence firing of the valve 4. It is possible. And here one was taking here and finally it is coming here. So what happens before this point E? Possibility was that your 1 and 2 is continuously conducting, or the possibility was that 1, 2 and 3 are conducting. Are you getting my point? Here what I want to tell, that this period is very larger, this period can be lesser as well depending upon the circuit condition. So here in this figure it is shows that here this is exceeding even though at firing instant of 4. So what happens at this 4 will be getting the pulse in the sequence order 60 degree. So at this E you can say 1, 2 and 3 were conducting because the commutation between 1 and 3 was even though still continuing, and 2 was earlier conducting and now 4 got the pulse. So 1, 2, 3, 4 are conducting at this time. I will also show you just after this another slide that let's suppose it has occurred before, then what will be the output? So here the 4 got the pulse and it will conduct because the voltage across this you have to see what is happening. When your 1, 2, 3 are conducting, now 1, 2, 3 here conducting, this will be EC by 2 minus this is the C is conducting. Now you can see it is your C and it is your E, so ECA should be positive. So EC minus EA should be positive, then only 4 will conduct, otherwise it will not conduct. Now see at this point E, come here, now EC is this and your A is this. So positive minus negative, negative, then it will be still positive and that 4 will conduct. So 4 will conduct. Now you can see there is a 2 commutation is occurring here, another is part of the upper valve, this is still 1 and 3 commutation failure is occurring because 1 is taking back here the current and 3 is going to, here 2 and 4 are also getting here. And now what happens in this period, the 2 and 4 you can see once this happens the commutation is here is over in between even the U, and this is taking your normal U period of the commutation here, and then here now you can say at the G point your here it is a 4 and upper one is 1, and this is basically nothing but your dead short circuit here because 1 and 4 are conducting, means you are having the DC short circuit. There is a one condition, as I said, there is a conduction of 1, 2, 3 and 4 here, and 1 and 3 here the commutation failure occurs even though the 2, 4 commutation is going to take place. Means you can see here at this figure, this is here this commutation between 2 and 4 is this period U, but this is a 1 and 3 here, this period is a before that. So in this section what happens, it is 1, 2 and 4 are there conducting at a time. So that's why corresponding to this you can see what is the voltage in this period. Now we have to just see here, if you have this 4 is going to fire and there is a voltage 1, 2, 3 and 4 are conducting, what will be the output voltage? Means at the point E I want to see what is the positive. No doubt the line to line voltage will be 0. The difference between the positive and negative will be 0 because there is a dead short circuit. But here since these are conducting here, these are conducting here, so the voltages here will be the different. Here once 1 and 3 is conducting, it is of course minus EC by 2. Here 2 and 4 are conducting, it is minus EB by 2 will be there. And you can see here at this point, here at this point your this will be the this is a minus EC by 2 and this is going to be here suddenly this is both will be equal. If both is not equal, then it will be not 0 because this whatever this is going to commutation takes place here, it is a minus EB by 2, this will be also EB by 2 because this is a dead short circuit which is appearing here. So both positive and negative should be same, then otherwise the difference is 0, because this is dead short circuit here. So here you can say both are here, and during this 1, 2, 4 here, this is going to be 0. Now once here it is going to be 0 during this period when commutation between 1 and 3 is unsuccessful, and now 1 got the complete current. Now lower one is still it is a continuing 2 and 4 is there. Now you can see what is your positive and what is your negative voltage. Now this 1 and here this is still continuing. So this is your minus EB by 2, it will be there, and this is the same polarity will be there in this side, because this is conducting, so this voltage will be there. So both this pulse will be nothing but your minus EB by 2 here. Once the commutation is over, then 1 and 4 are conducting, means your both side it is your voltage EA will be there. Once this is conducting, here is the EA, this is conducting, here is the EA, when there's no two valves are conducting in the bridge. So both are following EA, means EA minus EA will be 0, and you can see here the output voltage is going to be 0 here, and it is going to follow here. Now at this point H here, now it is the turn of valve 5 at this point H, because every 60 degree here 60, this 60, every 60 we are giving the pulse, the 5 will be given the pulse at this point. Once 1 and 4 are conducting here, this will be your C and it is your EA, so ECA must be positive, then only 5 will conduct. Now you see whether it is at this point what is the voltage. Now where is the C? This is your condition, your C is this, C minus this. So more positive is negative than C, so it will be negative voltage. From line to line also we can see. So it will not conduct at all. So what will happen? Now it will again continue, and you can say this follows the same, voltage will be 0, and now this is a turn of your valve 6, because after this 60 degree we are giving the pulse to 6, and you will see the lower here there will be commutation, because the voltage across 6 will be the positive. How come? You can see here this is EA is here and it is a B, so EAB should be positive. So you can see EA minus EB, here EA, now this is your EB and this will be positive. It is a positive, minus negative, so it is positive and it will conduct, and you can see there is a commutation is happening between 4 and 6 and it will be successful. Now at this point your again 1 is conducting and here that 6 is conducting. Now at this point L, now the turn off it is valve 1, after 6 1 2 again, and 1 is already conducting, so it will conduct. So it is again continuing, this 6 is also continuing. Now this is the at this point M, now this is turn off 2 and 2 here, what happens? It will be, if commutation is there, so 6 and 2 will be successful, and then we are going to have 1 and 2 conduction, and we find now this regular pattern is arising. You can 1 2 here, again we are here. So during this period only something happens. Sometimes you can say the voltage is 0. Here some positive voltage is also appearing across your inverter, instantaneous voltage, but average will be no doubt negative, and the voltage will be reduced, and it will introduce a lot of harmonics in the system, the DC harmonics as well as the current also, because you can say current is not as per our required practice in the phases A, B, C. So that will also introduce lot of harmonics to the AC side as well as the DC side. Of course it will give the harmonic. So this is the case when we assume that this is going to exceed this value, means is the 4, and we said it is still this commutation was occurring between here and it was exceeding when the before this after your firing instant of 5. Now let us take the case when this was over, commutation was failed before the 4, then your voltage will be something different and it will be not in this case. So in this case let us see the, again we can now draw, because that picture was very complex and it was not clear. Now here I am going to draw and we'll see how it is going to happen. Now as our initial condition here, this I am taking as EBA is the commutation voltage of valve 3. Then I have to write line to line voltages. Here I have to write it is a ECB, here it is EAC, and here again I have to write EBA, because and here it is AB, here it will be reverse of this, it is EBC, here it will be ECA, and this will be your EBC. I am drawing the line to line voltage. Okay. Now you can see this is the commutation voltage of your, this EBA is your commutation voltage, and now this will be, I am taking the condition of the valve 3 should be fired, because this is your 0 axis here and this is your beta degree, and I am taking this is equal to your 30 degree, because this is a 60 degree, this point here, this is your 60, here this is 60, so it is complete 180 degree. So 30 degree I am assuming, and you know then what was your previous case here, your valve 2 timing will be this, valve 1 will be this, and here your valve 4 will be this. Just we have to write the your ordinary is here 5, here your 6, here again it is 1, and here your 2 is again. So these are the valve conduction, means the pattern, gate patterns which is given to all the valves after 60 degree. So we can draw this. Suppose the 1 is here being fired, means before that your 6 and 5 and 6 were conducting during this period. Here there will be some commutation between this period, and I can say here 6 and 1 will be conducting, and between this period your 5, 6 and 1 will be conducting. Okay. So once your 5 and 6 were conducting, what will be the output voltage here? I am talking about this minus this. So 5 and 6 here it is a C, here it is a B, so it is ECB should be the voltage, and see where is the ECB. ECB, this is your ECB here, so means this was your, see this is ECB here, so this is your ECB was there, and now I gave the pulse to 1, 5, 6, 1 are conducting, means the commutation here will take place. So this voltage here will be minus EB by 2, and here it was EB, so 1.5 EB by, no, minus it will be there, because this minus here this 6 is conducting, so it is a EB, here minus means 0.5 EB, so it will be minus 1.5 EB by yeah, as a 3 by 2 it is 1.5 EB only. Now what will this will be? This will be just, it will be here, as if you will see it will be somewhere here. So what happens here, it will be here the commutation, and then your commutation is over. Now your 1 and 2 are conducting, means here it is EA, and here it is 1 and 6, sorry. So it will be B, and here 1, so A and B will be there, and AB is where? Here this is AB, so it will be coming here, and then it will be coming up to here at this point. Okay, because this is, you can say this is a voltage, EAB is there. So just how I draw here, I just check here EAB here, this is going to be here, so it will follow EAB. Now at the point 2, now we are giving the pulse to here gate 2, valve 2, and now there will be commutation between 6 and 2 will happen, and we will find the sequence. Now you can see from here the voltage, you will find the voltage here will be again like this, it will be here, it is going something here, and then again the voltage will be like this. Means at this point here during this your 1 and 2 are conducting, means it will be once 1 and 2 are conducting, you can see 1 is your EA, here EC, AC, A minus C, so EAC will be the voltage here, it will be coming. Now here at 3, as per our previous case, now here we are giving the pulse to 3, here I am not delaying now, I am giving the pulse and it is conducting. But due to some problem here the network side, the commutation is going to be longer, and we will see what happens. Now once here 3 is given pulse, now your the voltage here between now 1 and 3, now it will be your voltage will come here like this. Now what happens, I am telling that's the here is going to be this, and before the 4 is going to ignite, now this 3 is going to be off. Means during this period your 1, 2, 3 are conducting. Now at this point, now 3 is off, as because the current here took place. See, the means here your this is your 1 now going to be here the current, and this was taken care, and finally it is going to be 0, and before this it is commutation is failure. So now at this point here I am assuming now here your again 1 and 2 are conducting because 3 is off. It took the some current and went back, and it was off because the polarity was reversing. Now polarity was not reversing, but due to the decrease it was off, and 1 is 2 is taking complete current, and it will be certainly to off after this. Now here 1 and 2 is conducting, then what will be the voltage again?
Yes.
EAC is here, it will be coming here, and this will be your voltage. Okay. Now your 4 is given a pulse, and it will be the positive. You can see the voltage across this is a positive, and it will conduct. So at this point here, this is a sequence of valve 4, and it will be given pulse, and it will be conducting. So now your valve 1, 2, 4 are conducting, means 1, 2 and 4, and this is here the dead short circuit, and this is the DC voltage will be 0, means we are going to have here the certain voltage here at 0. Now here at this point there will be some here period where 1, 2 and 4 will be conducting, means there will be commutation between 2 and 4, and it will be successful, and then later on what happens, your 1 and 4 are conducting now starting from here. So till 1 and 4 are conducting, now the DC output voltage will be 0, and now we have to come at the point 5 where the valve 5 was expecting a gate pulse. Now we are giving the gate pulse, is similar to the previous case, and we will find this it is the voltage across this is not positive. You can also check from here, this once your 1 and 4 are conducting, here is a C, so ECA should be positive, but ECA is not positive, because ECA you can see here your ECA is this one, this is your ECA, and you can say this is negative, it will not conduct. So what will happen, now this will be not conduct at all, and now we are again going to have 1 and 4 conduction till 6. So your output voltage here line to line will come here up to this. Now the 6 is getting command, 6 is getting here, and there is a commutation here between your 1, 4, 6, means 4 and 6 there will be commutation, and it will be successful. So once there is 1, 4, 6 now here, 1 and 4 till their output voltage here will be the 0. So in this case also here it will be up to this point, it will be 0. Now here I can say this is here, now your 6 and 1 are conducting, now your voltage will follow, we'll see EAB, because 1 and 6 here, A and B we have to see EAB, and your EAB is very near to here, and it will follow here, and it will go up to 1. Now 6, 1 is conducting, and we are giving gate pulse to 1, it will be still conducting, so it will continue, so it will come here up to here. Now this is turn off 2. Now once you are giving the pulse here, now there is a commutation between 6, 1, 2, so means 6, 2 commutation is there, and it will be now taking place as usual here, and now this voltage will repeat. So now we have come back here, you can say now we are here. So this is a complete cycle, and now this is your output voltage here will be changed here compared to the previous one. Yeah, at that time it was directly DC here, because we were coming outside here. Similarly in this case, now you can is very careful, suppose it is asked to draw the valve voltage across any, so this side you should be very careful what will be the valve. It is, I can say let us draw the valve of valve your 5. then you have to see where it is going, what will be the voltage here, what is not. And that will be not a symmetrical pattern, of course, because here you can say during this period, once commutation failure is happening, we are getting not a symmetrical pattern, so valve voltages also will be the different. So you can draw similarly, this is a DC output voltage, it can be asked what is your valve voltage, just it will be coming somewhere here on this plane, and then you can draw. So the procedure is same, you should be very careful, just this commutation period as well as non-commutation period, you have to find the voltage and then you have to trace the figure. Now let us talk about the double commutation failure. The case which I am going to consider here, it is just similar to the previous case. Here it is said the unsuccessful commutation from 1 to 4 and back to 1 is completed before 4 fires. Just I draw the previous diagram, just it was the case, it was fires, and it the condition that the first failure persists and may cause the second one. Now the question, why 1 and 3 were unsuccessful? There was some cause, maybe due to the low voltage AC or maybe the DC. Let's suppose same it is a persisting, and 3 here it was failed, and then next 4 is commutation between 2 and 4 is also failed, and then it is a double commutation failure. So that's why here it is said that the commutation between 2 and 4 it is not taking completely, and again instead earlier in this case I said the commutation between 2 and 4 was successful. I am saying it is not successful, means again the 2 is taking complete current and 4 is off. So now 1 and 2 are conducting. So what will be the output voltage? Similar to the previous case, we can just draw now very quickly here. It is your EBA. I can write here it is ECB. Here it is AC, and now it is your ECA. Here EBC. Here it is your EAB. Here it is your EBC, and so on and so forth. Now here I am going to start directly from the 3, because your 3 is here, we are taking at this case the 3 is to be fired, here your 2, here it is your 1. Just I have to draw the sequence here. Again I have taken beta is your 30 degree, means alpha is 150 degree. So it is 5, here it is 6, here it is 1, and here it is your 2 again. Okay. Now before this here it was everything was okay, means the 2 was fired, there was some voltage here, it was like here, and then again it was going to be like this, means before that it was similar pattern. I can say it was here, then it was like this, and this was the output voltage, means your sequence was there between here. I can say your 6 1 was conducting here, here 6 1 2, then here 1 2 sorry 1 and 2, then here we are giving pulse to 3. So the similar here case, you are giving this, the voltage here 1 and 3 commutation is taking place, and now it will be going like this. Okay. Now before this here, as the condition is, before that the commutation is failed, and your at this point again here in this condition your 1 2 3 are conducting during this period. During this period your 1 and 2 are conducting, because 3 took the current but it went back, it is off, and now 1 2 are conducting. So 1 and 2 are conducting, your voltage will be EAC, and it will follow here this portion. Till here is a similar to just what I draw in the previous case. Now the 4 here we get the pulse, and now the commutation between here the period is 1 2 and 4, means the commutation between 1 and 4 2 and 4 was taking place, and again it was not successful. But mind it, here if this 1 and 4 are there, your output voltage is going to be 0 here. Okay. And what happens here, during this period some u degree the commutation was unsuccessful, and then finally it is again at this point 1 and 2 are conducting. Then what will happen? Again it will follow EAC, it will follow of course, yeah, 1 and 2 is conducting, so it will be always 1 and C is here because this was taking place but it is not successful, and finally here this is a, it is off. Now EAC will be there of course, and EAC we have to see where is your voltage. Again it depends, it is coming here or it is taking more time, means it depends how much U is taking. If it is U is here, then it will follow here. If it is coming here, then it will go here.
Yes.
So and then it will be here, it will be going up to this point. We are assuming that this is a taking longer time. If it is coming, as I said here, how much degree it is, commutation failure period is there. If it is before, then it will come here and then it will follow this EC. It's no doubt about it. Now this is going to here, and now we are going to fire the 5. Now once 1 and 2 are conducting, you can see 5 is still negative. See, 1 is conducting here and 2 is conducting, means you see ECA is negative. Where is the ECA? You can say it is a positive AC, so it will be negative, it will not conduct. And once it will not conduct, then it will continue till the turn of 6. So, okay. Now let us see the wall voltage 6. 1 and 2 are conducting. Here it is C, so it is CB. We require the ECB should be positive. See, ECB is, where is the ECB? ECB here, the BC is positive, so here it is your ECB is negative, it will not conduct. So still we have to go further, and then we are reached here. Okay. Now you are giving gate pulse to 1 and it is conducting, so it will continue to conduct. So it will further move. Now we have reached here. Now still 2 is conducting and we are giving pulse, it will continue it. So it will come here. And then the third will come, and if there is no commutation failure, there is a commutation between 1 and 3 will be there, and it will be coming back here similar to this point. We are here basically. This curve from the 2 onwards, we are here basically, you can see. So it is here at this point. This curve is similar to this, and then if commutation is not failing, then we will have the sequence pattern like this voltages, and we are having. Now you can see here the scenario is totally different than the previous in the double commutation failure. In one cycle is the 2 commutation failures occur. This is a very, very severe condition of the inverter, and then it should be very properly, it should be monitored. So that's why here I have written the in event of the this figure basically similar to what I draw, because it was not very clear. Now you can see we are getting the similar pattern. Here our this voltage, you can see this is your 3 and 1 commutation here failure. Then it was before that 4 was fired here, the commutation was unsuccessful. Here between this your 1 and 2 were conducting. Then here 4 was given pulse. It was certainly short circuit. Here 5 we tried to, no, here the commutation was over between fail again 2 and 4. Then the voltage came here, then we found here 5, it was because it is a negative voltage. Then we give 6 negative voltage, then we give 1, already it was conducting, then we give 2, it was already conducting, then here again we are coming 3, and then it is continuing. So here you can say in one cycle now the almost the average voltage is going to be 0 rather than negative, and that is a very severe case. So that's why it is written in the event of the commutation failure persist, then the bridge in which it is occurring. Why I am talking the bridge? Because there may be the series of the bridges for the same to lift the voltage. So if any of the bridge it is persisting continuously, it should be blocked or it should be bypassed, otherwise it is creating lot of power problem in your controller as well, because current is changing very haphazardly. Also the voltage is going to change, your controller keep on working, and that's is the controller may not be able to find the optimal solution, and there is another consequences may occur. So that's why here you can say this is it. So you can say these are the conditions. If it is a persisting, it should be bypassed. But there is a possibility. Now the question, if the commutation failure is occurring due to the low voltage AC here, so of course there is a problem. This here, the low voltage here, as I can say, this was the unsuccessful, next will be also unsuccessful. That's very much guaranteed, because if this voltage is less, so there is also you will be larger and your this controller will. So it may make cause. So, but if it is a voltage is coming to normal, then it may not be commutation failure. But if it is a continuously low voltage, then we have to act our video call so that we can go for the reduction of the voltage and we can operate accordingly. So that's why here the CA control basically try to control the here. If this is unsuccessful here, we have to take care of in the CA control, so that we have to fire in advance, not to delay it, to avoid. So these are the basically measures and cure of basically I can say the commutation failure. So in this we just analyze, as I said, the different scenarios are possible for the commutation failure. How much time of the commutation duration is occurring, that is a major concern. It can go for the longer period, it can go for the lesser period. All this depends upon your the AC side condition, your DC side conditions, and based on that the commutation failure is there. So in inverter circuit, this is a very common and very persistent phenomena, and if it is a one commutation fail is occurring in one cycle and it is over, hardly matter. But it should not be the continuously occurring, otherwise even though your bridges are going to be highly stressed, the voltage across that, it is always going to be very sudden changes here and there. So it should be properly taken care. So that's why if double commutation failure is occurring, means there is some problem in maybe the bridge also, and then it should be blocked and bypassed properly. So this ends your commutation failure, and that's why I explained very clearly that the commutation failure must be understood very properly, because it's a very common phenomena, and here there is no protection scheme for this commutation failure because it's a self-clearing. But if it is a persisting continuously, then we have to take care and we have to bypass or block the bridge. So with this I should close this, and in the next lecture, in lecture number 3, we will discuss about the protection schemes. Maybe we use the differential protection, we will see other over voltage protection, all the protection now we have to discuss in the combined way. Thus we have to safeguard our converter and HVDC lines. So in the next lecture number 3, we will discuss the protection schemes for this HVDC link. Thank you.